Okay, I'm doing a reassessment video on forces, and I just made up a problem, and I'm going to do what is the tension in the rope of a box that's moving when the mass of the box is 2.2 kilograms and the coefficient of friction is 0.26 newtons. So what is the tension in the rope of this rope? So the free body diagram of the box is the force of friction, force kinetic friction in the negative direction, the tension of the rope, which is 38 degrees, the normal force, and the force of gravity. So the sum of forces in the y direction are n plus t times sine of theta that we get because it's the opposite over adjacent angle, and then minus the force of gravity. And then later we'll need to solve for n, and n equals force of gravity minus t times sine of theta. Sum of forces in the x direction is t times cosine of theta minus the force of friction. And we can plug in the force of friction equals the coefficient of friction times the normal force. We'll plug that in. We get t cosine theta minus coefficient of friction times normal force. So we can plug this right here, the normal force, into the normal force right here, and we get t times cosine of theta equals mu k times mg minus t sine of theta. And we solve a lot of things around, move a lot of things around, get t to one side, factor out a t, and factor out a t, divide by cosine theta minus mu k sine theta, and we get t equals coefficient of friction times the force of gravity divided by cosine theta minus mu k sine of theta. And we plug in the numbers here, and we get the tension of the rope is 6.38